Hi there, thanks for coming out. My name is Sean Askay, and I'm a developer advocate here at Google, as well as the tech lead for KML. I'm here with Mano today, who's also a developer advocate, and we're going to be talking about KML, high-performance KML, and some other cool things. So on the screen, this is an embedded Google Earth plugin, and this is actually a KML Tour that I'm using to animate some polygons. We'll talk more about that in a second. So a quick overview of what we're going to talk about. I'll give a very brief intro to what KML is. Then I'll start talking about data visualization using KML. And then Mano will take over and talk about developer environments for KML authoring. And then KML rendering and maps API and using KML with fusion tables. So a really brief intro to KML. Keyhole markup language was developed at Keyhole before the company was acquired by Google. It's basically a data language that represents spatial data and styling, kind of loosely like HTML and CSS is to the web. KMLs can be static files that you can serve off of your server or run locally on your machine. It can also be generated dynamically via web services and served to Google Earth and Maps. Google gave KML to the Open Geospatial Consortium in 2008. It's now an open standard used by Google's Geo tools and a bunch of other third-party tools as well. And at last count, there's well over 1 billion KML files out there on the internet. They're not all necessarily interesting. Unfortunately, most of the ones out there look like this. It's basically, this is my house. So here's the KML for a very simple Placemark, rocket ship, description, goodbye world, and some coordinates. And this is what it looks like in Google Earth. I want to talk about a lot more exciting things than just point placemarks, specifically data visualization. I'm going to speak to thematic mapping, how to take data and visualize it on the globe, and then also talk about things like GPS data and tracking objects through time and space. So in a little more detail, I'll be talking about 3D extruded polygons using a new KML tag called altitude offset, which makes it a lot easier to create these three-dimensional polygons. Then we'll talk about animating those polygons with Google Earth tours. And then I'll switch to the objects in motion, GPS stuff, and talk a little bit about GX tracks. And then finally talk about bringing in like a real-time data feed to update GPS tracks on a client. The basic themes here are interesting new ways of visualizing data, and then how to keep it updated and fresh, and then how to animate it. So thematic mapping is basically taking information with a geographic context like census population data or demographics, and then visualizing it on a map. So here we have two examples. One is showing some 3D spheres using 3D SketchUp models that are scaled in proportion to some data value. And the other one here are these 3D extruded polygons, which I'll be talking about first. So basically, before we introduced the GX altitude offset tag, you had to specify an altitude for every single vertex in the polygon, which is kind of redundant, wastes a lot of space, and makes it very difficult to do animations and updates on those features. Now with the altitude offset tag, altitude is globally set for the entire feature. So here's a little code to show you what a placemark with a polygon looks like. This is the way we used to do it, where you had the altitude values after the longitude and latitude for every single vertex. Now we basically can specify, like I said, altitude offset at a global level, and that cascades down to all of the placemarks underneath. So I'm going to give you a little demo of what you can do with these types of animations. And the question here is, what can you do with Google Earth? I basically spent the weekend digging through census records, American Community Survey records, state and county polygon maps, and then used fusion tables, Google Refine, Google Charts API, Python using a library called PyKML, and a weekend I would rather spend outside to do some cool stuff. So we're going to essentially show you some live demos that look a little bit like this. So here's Google Earth. I'm going to load the KML that I made. It's enormous. It's about 40 megabytes uncompressed because there's so much data. This is pretty simple. Mouse over, you can see polygons for each state. As you zoom in, we fade to county borders. So I can mouse over and get each of the county names, zoom in further, and then those will fade out, and I'm left with these white lines demarking the edges of the counties. So this isn't all that interesting by itself, but I can use a Google Earth Tour to do some animations with it. A Google Earth Tour is basically a set of camera flight paths and animations that alter the content. So I'm going to start off one of these. The first data set we're going to look at are the percentage of kids in each state that are lacking health insurance from 1987 to 2009. And as you can see, these are all moving around. I can pause the tour. When I mouse over it, I now have the name of the state, and it's a little hard to read, but the percentage of kids in that state for that year that don't have health insurance. I can click on it, and then using the Charts API, I'm rendering this out over time. So here we're looking at 2003, and the value is 19.4. I can hit play, and we'll continue with the tour. I can pause it. I can play with the time slider, drag it back and forth to any particular date, and then zoom around and check things out. And I'll note that Massachusetts is the best state in the nation for health care for kids. So go Massachusetts. It'd be interesting to kind of do a mashup with the red and blue states on this as well. I kind of wonder if you'd see anything. So that's this tour. Let's take a look at another one. We're going to look at houses, percentage of houses that are lacking complete indoor plumbing. Going back to the 1940s, a lot of people in the States didn't have indoor plumbing. Here, Texas has 62% of the households without household plumbing. I hit play, and then each year, as you might imagine, that drops. Alaska popped up in the background because we didn't have data for Alaska in 1940. And then we finished in 1990, where almost the entire country now has indoor plumbing, and there's the graph. One last data set I'll show is looking at population data on a county level. So I'm going to zoom in to California, and I'm going to hit play on that. This is the biggest tour. There's a lot of polygons, so my little laptop has trouble with this sometimes. I also decided to take out the smooth transitions with the extruded polygons and just snap them to different altitudes, which helps improve in performance. So again, surprise, surprise, Los Angeles is growing like crazy. And you can also see the Bay Area picking up here as well. I can zoom out, I can pick one, check out the data for it. There's LA, or fly anywhere else in the country and check out the data there. So, whoops, let's go to Chicago. So one of the interesting things I kind of noticed about this data set with Chicago was maybe suburban sprawl popping up. So I'm going to restart this animation. This is Cook County, I believe, which is where Chicago is. And this will come online. So as you imagine, Chicago, big city, lots of people. It keeps going up and up and up and up. But I think in the 60s and 70s, it actually starts to drop a little bit. And you'll notice that as it's dropping, these other counties around it are starting to pick up. So I'm not an expert in the region, but this might be an example of suburban sprawl. Something that you could see with a data set like this when you're viewing it in three-dimensional space. So let's turn this off and head back to talk about how this is done. So we basically want to animate a polygon in the context of a tour using the animate update tag. So here's a very simple Placemark. We specify a polygon. There's that altitude offset and a bunch of coordinates, which I'm not showing you. And elsewhere in the same file, I have a KML Tour, which defines these animations and these camera motions. And here you can see over the course of 3 seconds, we're going to change that altitude, to 1,000. That should be 100. So what you'll see in the next slide is that was actually supposed to be 10,000. That polygon now gets raised higher. We add an extra 0 here, and off we go. So this is basically how you would do an animated update to extrude that polygon to a different altitude. You can do more than just extruding polygons and making them taller. You can actually interpolate between almost any values in KML. So let's check out another demo. So this is just kind of a visual, no particular data attached to it, but it's kind of cool looking. We're going to fly in, and here we have these circle polygons that are expanding in time. So the original polygon is a small circle, and then I'm saying over 3 seconds, change to these coordinates, which are a bigger, like a bigger set of coordinates, bigger ring. So that's going to basically make these animate and expand out. And again, this time you notice the camera was moving with the tour because I have recorded a flight path with it as well. All right. Another way of doing thematic maps, and I'm going to rush through this a little bit so we can get to the GPS session, is to use 3D SketchUp models instead. So here's SketchUp. We've got a model of a cell phone. This screenshot comes from thematicmapping.org, an awesome website. They have an API for creating thematic maps, although the animations aren't done quite the same way as I'm showing here. Basically, you got a place mark. You specify the location, the scale, and the model file. Just like with the previous example, here's my original model. I can bring in that KML Tour, and I can say, hey, scale, I want to extrude you. I want to make you bigger in the y dimension by a factor of 10. So our new cell phone gets a lot bigger. The value here changes to 1,000, and off we go. So the next thing I'm going to talk about is GPS type data and what you can do with that in Google Earth. So let's do a couple quick demos to show you what that looks like. I'm going to load some data. So the entire geo team at Google took an off-site field trip not too long ago. We all went to Lake Tahoe, and we all went skiing. And we had a bunch of people run around with GPS units, which was pretty cool. Which means that I can drag the time slider, and you can see all kinds of Googlers running around the slopes, skiing, snowboarding, et cetera. In addition to manipulating the time slider manually, I have a tour that'll do it for me, and it'll do a camera path, and it'll do a nice advancement of the time slider so we can get a visualization here. So this is me on a dog sled ride. So I'll fast forward through a bit of this, and then you can watch everyone going up the ski slopes and then skiing down. One other example of this is taking a 3D model and actually showing that in the context of a GPS track. So a couple years back, I made a tour for the Apollo 11 landing on the moon. And now this is when I regret OK, internet's fine. I was worried there for a second. I created a tour that basically shows the path of the Apollo 11 lander coming in to land on the moon. Let's turn off some other layers here, keep the imagery, keep the terrain. So back then, we didn't have this GPS track feature. So I basically had to create animated updates to move that model segment by segment along the path. Now, fortunately, I don't have to do that. I can actually just drag the time slider if we know when and where that model was. We'll zoom out a little bit, like that, and you can bring it in. So I can make a tour animating the lander a lot easier now just using this GX track feature. So let's talk about how that's done. The way this used to be done is people would basically take a bunch of place marks or a bunch of lines, they'd put a timestamp or a time span feature on it, and you'd play with the time slider, and you're essentially duplicating this same object over and over and over and over again to animate it. Now we have a single place mark, a single feature through time and space. It's the GX tag we'll show in a second. This currently only works in Google Earth 5.2. So you're not going to be able to do this in Google Maps. Obviously, you can't do 3D stuff or tours in Maps either. As I said, you can use 2D models or 3D models. And as I'll talk about in a second, you can add extended data, additional attribute data correlated to the time and the path of the object, like if you're riding a bike, heartbeat, or if you're driving a car, RPMs. So basically, the way this looks in the KML, it's a set of parallel arrays. You've got a bunch of when statements that define timestamps for each segment along the path. You've got coordinates that say where you were at that time. And if you're using a 3D model, you specify the different rotations of that model, the orientation of that model. This can be a little hard to author because it's a parallel array, and if you're writing code, it'd be nice to kind of iterate through each different time step. So as long as you don't tell the Schema Monster, you can basically interleave these. This won't schema validate, but Google Earth will read it just fine, and if you save it back out, it will put everything in its proper order. So let's take a look at a little bit of demo, another demo, looking at a bike track of a coworker who took heartbeat data along the way. So we're going to switch back to Google Earth. Go internet. All right, and then I'm going to load the bike track. We're going to fly down here. So Peter's in the room, actually. This is his track. And you'll see that I can click anywhere along the track and get his heart rate at that particular point. I can also right-click on the track and show elevation profile. This will basically show a graph of his speed, the altitude at the time, and his heart rate, in this case, as an additional data set. So here is his heart rate during the course of the trip. So let's look at how you do that in KML. So again, this part is the same, a bunch of when and chord statements defining when and where the person was or the object was. Then you're using the extended data tag, and you're specifying a simple array called heart rate and another parallel array that goes and correlates with each of these. So this is what allows you to basically take any variable you want and sync it up with the GPS track. So that's kind of cool, but I want to show something even cooler, which is what if you wanted to stream in real-time data, have a data feed come in and basically push the locations of an object to the client? So let's take a look at that. So I was in Kenya some time back, and I had the luck of going in a Cessna with an old salty pilot who took us on this kind of crazy tour around Mount Kenya, which is north of Nairobi. So what's happening here is I'm fetching each segment of this track a piece at a time. So the initial file only had the initial little piece that you saw, and each additional network fetch that I make, I am grabbing additional data, injecting it into the track. So doing something like this, you could basically pull in real-time feeds of latitude, Google Latitude data. If you have any other devices that are streaming their location, you could visualize it like this, a segment at a time, and push out the real-time locations and the track in between now and the last update. So we're going to land here in a second, and then I'll show you guys how this is done in the KML. So conceptually, what's happening here is we have two network links. A network link is a KML feature that basically fetches from a URL some KML. So the first network link fetches an initial file that just contains maybe the first little segment, maybe up to the current location of the object. Then there's a second network link that hits the server and says, well, give me any updates that have happened since I last checked in with you. So here you've got Google Earth. Here's your initial request. This could either be static files, which is what I showed you a second ago, or it could be a live web service. And then updates are going to come through that second connection to your web service. So here is kind of a zoom of that left panel that I was showing you a second ago. Here's the network link to the original file. That fetched the initial track. And then I have underneath it a second network link that fetches the updates. So this is how it would look. This is how you'd make it. Here's your Placemark. And instead of using a regular track, I'm going to use a multi-track. Since GPS data tends to be segmented, you turn your GPS on or off, and you want to maybe visualize your entire trip, you can actually combine multiple tracks into a single Placemark feature. So I've got a single multi-track here with the first segment of data, Sean T1. And I should mention that we grabbed that from maybe GPSPy, which is our initial file fetch, our first network link. Then I hit web/feed.py, which gives the updates. And that's what this looks like. This is using what's called a network link control. It's another feature of KML that basically says, hey, update this item. It's a little similar to the animated update you guys saw before. This is actually the precursor to tours. This was just basically created to basically stream content to a client and change it on the fly like this. The other thing that we do here is we send with this second file a cookie, which is appended onto the end of the URL, which says, hey, this is the last time I got data. I'm giving you data up to this point. And you'll see how that's used in a second. So what's going to happen is this track is going to get bumped up over here. So now we have track number 2, and we can see our track was updated. That last parameter was appended to the feed file, to the feed URL. such that the next time you fetch, your server can say, hey, OK, I know that he had everything up through this date, so now I'm going to update him with everything through this date and give him a new track that contains all that additional data. So anyway, in summary, here's what we talked about. A little bit about thematic mapping and using these 3D extruded polygons with the altitude offset tag, which makes it a lot easier to author the content, and also allows us to make these time animations using Google Earth Tours using the animated update tag. And then I just finished the section on objects in motion, looking at GX track as a feature to look at GPS data, and then how to use the update tag with a network link control to basically push new data into that track. So I just launched a new blog today called at unchartable.com, and I'm going to start talking about KML techniques like this in the future. And with that, I'm going to hand it over to Mano.
Thanks, Sean. Hi, am I on? I'm on. OK. Hey, last session of the day. Pretty exciting. I hope you're all having a great day today. Sean dared me to make this joke. The Android people are giving out tablets, and the Geo people are giving out free maps. So, yeah. All right, some of you laughed at any rate. OK, so Sean and I are developer advocates, which means this is our job, right? A big part of our job is to go out and talk to developers about actually doing code and the process of doing that. And we find that a lot of developers ask us specific questions about developer environments. Like, what are the kinds of things that you use to actually do your coding? So I'm going to toss a whole bunch of just sort of ideas and things that Sean and I do at you, but mostly, again, you know, as all coding is, it's really going to be questions of personal preference. There is no right single development environment for creating KML. So the things that we're going to talk about, I'm going to talk about briefly, are editors, validators, particular programming languages, and also mention some open source libraries that might be really useful for you. So particularly for the programming editor, this is something of personal choice. You know, generally your options are some sort of integrated development environment or just basic text editors. And I'm particularly fond of VI, and of course Sean is particularly fond of Emacs. So we have the classic older hacker kind of conflict, even though he's a lot younger than I am. You know, just some different ideas of the different things. The one place that we come together is on Notepad++. It's a nice Windows environment. We've got some nice script styling and some basic text editing, and if somebody could turn off their phone ringer, thank you. And then, of course, some people do prefer Eclipse or Visual Studios, which have some integrated XML editing environments. Personally, I just go with the classic VI because it's pretty much everywhere. Sorry, just had a little dig. Anyway, so XML Validator. So XML is a document format, right? And of course, the scale of things that we're talking about here, you're not really hand editing KML anymore, right? High performance KML, you're generating this KML programmatically. But there are times when you want to check the valid, you know, whether it's a valid output, and you want to actually do that by hand. And I'm particularly fond of Oxygen, which is a nice cross-platform Java-based validator. XMLSpy is something that's a lot of people are fond of. JEdit is something that Sean is fond of, and of course it's actually, I believe, free. And Notepad++ has some basic validation stuff built in. But of course, you can also directly validate using a number of different libraries, the classic being libxml, and then a bunch of language-specific ones. And then there's some KML-specific libraries that are helpful, PyKML, as Sean mentioned, and libKML. And then for programming languages, I think Sean and I are both most fond of Python as a language for doing this kind of coding, easy to get started on your scripting. And it's got support for libraries like libKML, PyKML, GDAL, OGR, those sort of things. And the one thing that's, a couple things that you need to take into consideration when you're thinking about what programming languages that you're working on is think about what your production environment's gonna actually look like. So many of you are gonna be very comfortable on your laptop or in your desktop doing some coding in whatever scripting language. If you want to be doing, you got your Ruby's on Rails environment or blah blah blah, whatever your particular kind of thing that you've got. But you got to think about how that's going to translate into a hosted environment, how it's going to translate it if you're going to be pushing that out to somebody. So it's often good to sort of start from that as a starting location. Things to think about that might not occur to you right away are things like Google App Engine doesn't currently allow you to support C++ libraries, anything but pure Python or Java. So those are the kind of decisions you're going to need to look at before you actually get started when you're creating a large scale application. And if you're, for instance, say pulling from a database, certain programming languages have better integration with different databases. So the classic being PHP and MySQL are pretty closely linked. There's tons of code that help you pull that data out there. And if you're doing something like interacting with a data API like Fusion Tables, what are the client libraries that you'll need? Okay. And just to give a quick call out to PyKML, you may be familiar with libKML, which was actually produced by Google engineers and is used in some production environments within Google. PyKML is a bit lighter weight. It supports primarily the core elements of KML, and it's written in Python, so it's got a very Pythonic interface. So just wanted to show you this as an example. Here, this is a pretty simple way of creating a KML document, which is one of those core container elements for KML. Adding in Atom and putting in the link so you're preserving attribution, and then creating a placemark. You may recognize 00 as Null Island in the old Myst game. It's also where a lot of KML with poorly configured latitude and longitude ends up automatically. This is the spot off the west coast of Africa. So if you're always wondering why there's this big cluster of things, it's like anything that Google Earth doesn't actually know how to place, it's going to either place it there or entirely off screen. So I like to use that in my examples. Okay, so that's just a simple PyKML example. So I want to switch gears here and talk about the Maps API, because Maps actually deals with KML in a very different way. I'm going to start with showing you some capabilities here. So this is a USGS KML file overlaid onto a Google Earth, Google Maps API application. And you'll see that the earthquakes are styled different colors based on their intensity, and I can click here, and you'll see in this to the right here, I've got the actual data there from the placemark that I clicked on. Now, you may notice that it's not actually pulling it into an info window, and that's because I've done some code to prevent it from doing that. So I just wanted to show you this to demonstrate that you can do something a bit interesting, which is you can actually load it in as a clickable raster overlay. So how many of you were in the Fusion Tables talk earlier? Okay, all of you, awesome. This is like the geo diehards here, right? Okay. So in that talk, James McGill described how Fusion Tables will render all your place marks into basically 40 tiles and place them onto a map. Well, KML goes through a very similar renderer. Basically, these are all rendered as a clickable raster overlay to increase performance. So you can put in quite a bit more place marks in KML than you can if you were loading this up using creating JavaScript objects. And it's created using this clickable raster overlay. But once you click on it, you actually actively get data out of it that can be captured and then manipulated and used. Okay, so people often ask me about this process and how it works. You basically create this KML layer object, and I'm going to show you the actual code for this in a minute, but this is the particular process. Place a KML file on a server. You create this KML layer object in your Maps API application, and then the Maps API lets Google servers know where that is. Google servers go out, fetch the KML file, and render it into this clickable raster overlay, which they pass back to your Maps API application. So this is why, and this is the question people always ask me is, why can't I put this KML file on my computer? Or why can't I put a password into this to prevent people from having, to prevent other people from getting access to it? It's because you can't pass that password on to Google server to let it know. It has to actually go out, fetch the KML, render it, and then pass it back. So any KML object used in the Maps API must be rendered onto a public server. Okay, I want to go back to the limitations in a second, but I wanted to show you the actual code since I actually talked about it. It's very simple. Here you've got this KML layer. You just create it, pass it a URL. Here I'm passing options to it, and here I have this suppress info window is true, and I set it to the map. And it looks like, and this should actually have my options in there. It looks like that got left out. And then here I'm adding a event listener to the KML layer on the click that takes the text from the KML feature. So when I click on it, it is able to capture that feature data, get the description, and then it shoves it into a div. So that's just a very simple explanation of what was happening before and why it wasn't showing up as an info window, it was showing up on this side. So let me talk about some of the limitations here for using the Maps API. So as Sean mentioned, we don't support full KML in the Google Maps API. And the reason for this is kind of twofold here. One is it's a 2D environment, right? You don't have a way of representing a 3D model. You don't have a way of representing elevation directly. There's a lot of different things that you don't have. And the other is that this process of having the server load the file and then send it back to the browser means that you've got lots of interaction between servers and clients and stuff going on. So there's very big performance considerations. So we have a relatively small file size for geographic data that's 10 megabytes maximum. And a limitation in the particular KML that's actually supported. And in this case, it's primarily the geometry data. We don't support very many of the extensions that Google has added, so the GX tours and the tracks and all those things that Sean was really excited about because they're incredibly powerful visualization tools. We don't support those in Maps just because of these limitations. And also for security reasons, because we're passing this off to a JavaScript application that may be sitting on a different server. So you notice that file that I actually loaded, the USGS file, was actually loaded directly from the USGS.com. So since it's being loaded from a different site, we have to actually be careful about cross-site scripting and all that sort of thing. So it'll scrape out JavaScript and Flash that's in the description balloons. So these are some of the kind of considerations that you'll need to think about when you're creating KML for the Google Maps API. And of course, it has to be on a public server with no password. By the way, that scraping out the JavaScript and Flash, you can put that back in by capturing the click event and putting it into creating a new info window if you want. Okay. So those are the major things I wanted to talk about for the Maps API. So things to be thinking about in these considerations is the primary thing is think about producing separate KML that's optimized for maps when you are producing producing KML. You have a set of data that's highly optimized for Earth and a set of data that's highly optimized for maps. And you can do this dynamically depending on the client that's querying it. You can send parameters to your network links or to whatever that are loading the data to change them if it's a Maps API application. Okay, so most of you were in the Fusion Tables talk, so I'm not going to actually go as deep into this as I was going to, because it doesn't seem like it would help to repeat it. But I want to talk about some basic things that you can do with Fusion Tables, so that these are captured. And anybody who's watching the video, take a look at the Fusion Tables talk as well. So this is a simple Maps API app that I wrote with a very simple Fusion table. I was a historian in a former life. And the idea here is that the boundaries of Poland have changed pretty dramatically over the years. And so I just wrote one that captured that and rendered these on a map. So you'll see here in 1492, these were the boundaries of Poland. In 1650, those were the boundaries of Poland. In 1815, it actually goes away when Prussia and Russia split Poland, and I believe Austria actually took a piece of it. And in 1920, these are the boundaries, and in 1945, you see they're the current boundaries there. So the things to note about this is all done with KML that is loaded into Fusion Tables. And what Fusion Tables does is, as you know from the previous talk, you load up tabular data, and it pushes it into Fusion Tables, and then you just click on Visualize Map, and you get a map. So the point here, though, is Fusion Tables supports KML in here. So when you're creating KML and you're uploading it to Fusion Tables, things to be aware of are that it's a smaller subset of KML than even the Maps API supports. It's basically just the geometries. So what it does is it takes the KML file and it strips out all the styling that you've done in your KML. So any styling that you're producing, you don't bother with it to create it. And it just strips out the geometries, and then it takes a look at the extended data elements. Now, extended data is where you can create basically name-value pairs of data for your KML features. So it then takes those extended data and turns that into columns. So things that you had in the description and the name, I think, are also transferred, and then nothing else comes along. So that includes things like timestamp and timespan elements. Okay. So the integration with the Maps API, as you will know from the previous session, is essentially one line of code. You can do additional things, as we've announced today, in styling these layers as they come through. And this is, again, just a summary of some of the things to do with our KML support. Again, it renders this clickable raster, just much like the KML layer does. And you can upload files up to 100 megabytes in a single file into Fusion Tables. Although a single table can actually be much larger, you can programmatically add data to files to get it up to 250 megabytes. That's for a single Gmail account. So this is your basic code sample for integrating with the Maps API. Here we've got a Fusion Table Layers object. You pass in a table ID, and then you can optionally add in a query, and this is from this Poland demo that I just showed you. Select geometry from table ID where year equals year, and set the layer to a map. Okay, so that's all we have on that right now. We are happy that you all are here, and we'd really like to take some questions. We would ask that if you have a question that you come up to one of the mics so that the questions can be recorded.
And a couple other things as well.
I guess we should both be on.
Apologies to Mano, I screwed up your code sample. I was converting all our slides to HTML5 this morning, and I think
no worries.
bad copy paste. If you guys have feedback about this talk, we'd love to hear it at Speaker Meter. The URL's down there. Tell us how bad or well we did. And questions?
Our organization's running ESRI, and they have a lot of jurisdictional data. It's highly accurate. It's very up to date. When I get the a supervisorial district KML file that they're going to generate off of a shape file, it's huge. Do you have any way of simplifying it to make it a smaller KML, shrink it a bit?
Yeah, so there's a number of techniques that
you
can use. The classic one to use is regionation. Regionation basically breaks down your file into simpler, say you're dealing with polygons, be a simpler polygon when viewed from a distance, and more complex polygons for portions of your data at lower points.
You might look at fusion tables if you didn't already attend that talk. If you do convert your shapefile to KML, you can put up to 1 million characters in each cell in fusion tables. So as long as one polygon doesn't have more than 1 million characters for the geometry, toss it in fusion tables, and we actually do quite well with really large geometries, really fine detail. The other thing is, do you really need all that detail in the KML?
Probably not.
In which case, I would recommend using the ESRI software that you have already. There are polygon simplification tools in ArcGIS that will simplify those polygons down and make them a lot easier to manage and deal in Google Earth.
Thank you.
So one additional point on that is actually Josh Livney, who's in the audience, wrote an application called Shape Escape, which allows you to upload a shapefile directly to fusion tables. It decomposes it, puts all the features and posts them using the Fusion Tables API into Fusion Tables, and it will simplify any KML that's too complex. It'll simplify polygons that have too many vertices.
Next question.
Yeah, a client asked me this question, and I hope I gave him the right answer. If you go ahead and load KML into Google Maps like that, that URL I pass you, does that end up in the Google search engine anywhere? In other words, could that data then be found elsewhere?
So
Repeat the question.
So the question is, if you create a KML layer using a Maps API application, does that URL then get passed on to
Elsewhere, Google,
to our web search or map search to allow it to be found in some other spot? No.
Yeah, no. Not that I'm aware of. I'd be shocked if it did. So.
That's what I told him, but
Yeah,
that's the best we're going to do is we'd
does
all
he
be
want
surprised.
It to be?
No, that's the point.
Okay.
You can't
There's
put on a
important.
password, but I told him, nobody's ever going to find it.
Sure.
Yeah, the other thing you might do if you're just really worried about it is put in a sitemap that specifies don't crawl the particular directory that that KML comes from.
I guess it depends how you're passing the URL in as well, because if you're doing that client side on JavaScript, someone could look at your page, like you say, and actually fish for the URLs. But if it's server side or something, or if you're obscuring the way that URL is passed, you'll be fine.
Right. If you're really concerned, you use Maps API Premier, upload it to Fusion Tables, and use the private Fusion Table option for Premier. That allows you to keep your table private, but still share it with the rest of the world.
Okay, thanks.
Sure.
I had 2 questions. First, when last I looked, I could not find a reasonable pure Java API for writing KML. I saw a number of JNI APIs, but those are hard to deploy and harder to work with. Oh, you're on Linux, I'm on Windows, blah, blah, blah. Is there a good pure Java way to make KML?
Not to my knowledge.
I'm not a Java guy, so not to my knowledge, no. Unfortunately.
You might be able to do something with, essentially KML is XML. right? So using the built-in libraries to do it, you could actually do
I could
something
write
fairly-
a Java
you could
API to
it,
write
exactly.
a KML.
And then you could post it to Google Code Hosting so that everybody could use it.
But how would I get
And
paid to do
I think
that?
there's a couple of people waving their hands who have
Oh,
some
you'll
ideas
pay me to do that.
about that. So, and if they could come up, yeah, it shouldn't be that hard, but at least one person may be coming up to the mic to announce one later. So,
To repeat that question, it was,
Oh.
is there a pure JavaScript library for creating KML?
not JavaScript,
Or
Java.
Java.
Yeah.
libKML, C++, but you could probably do swig bindings to Java, but that's not native Java.
And it poses cross-platform problems when, because the swig bindings for Windows don't work.
At least
really
with
well.
PyKML that I was showing earlier with Python, that's just an extension of libXML, C++ as well. So,
Yeah.
never mind.
A pure Java solution might be really useful, for instance, in a Java version of App Engine.
My other question is, when I'm doing development on my personal box behind a firewall, is there a dev mode or something where I could say, I've got some KML, I just want to post it to a place and then bring it right back? Whether I don't have to set up a sandbox and publish it onto sandbox with an URL. I have the KML in memory in JavaScript. Could somebody do something with it?
You mean for Maps API?
Yes, for Maps API.
So the question is there a way to load KML into a development environment on your personal laptop or desktop or whatever without having to post it to an environment so that the Google servers come and get it? No.
Too bad.
No, there's not.
Google has to come and get it. So if
Right.
you can't hit a server on your laptop,
That was the point of the diagram.
Dev
that
would even,
Google has to-
I would even send it to Google. The Maps tiles don't load if I'm not online. I can be online. What I want to do is be able to post it to Google directly and then have Google just send it right back to me as tiles,
Well,
rather
you
than
could
putting
use
it up
a-
in a place and waiting for you to come get it, which
I
is
mean,
harder for my firewall.
If you want to do that, you could use something like Google Storage for Developers or Google Code Hosting to upload it there and then grab the files off of that using the KML layer. So
Thank you.
certainly you could do that. Sorry?
Yes, punching a hole in my router is what I don't want to do.
Yeah, I never recommend punching a hole in your router so that Google servers can come in and look at it. Yeah.
Well, I was just going to say that I've marshaled from a feature collection in GeoTools into and out of a KML. So I think that's possible still. My question was about an element in KML that would allow me to take a georeferenced image that I already have, like say a historical map, I know the bounding box for it, and just bring it up in Google Earth. Is that possible?
So ground
yeah,
overlay.
there are a couple different ways of doing it. If you have a georeference file like a GeoTIFF, if you have Google Earth Pro or Google Earth Enterprise, that'll directly import, it'll convert it to a JPEG and then display it for you. There are also some regionation options with that if you have really high resolution rasters. But there are a lot of free tools as well. Goodle, or GDAL, depending on how I like to say it, is another open source library that will tile stuff for you. There's a tool called Goodle to Tiles. It's Python based and it'll convert it. There's also MapTiler. If you go to maptiler.org, it's a desktop app that will take georeferenced images and then generate KML for it.
Okay.
But not natively in KML. There's no way to say, here's my random raster proprietary format, bring it in. You actually have to do a conversion process to native KML.
To native KML, but it will reference an image file like a GIF or something, and then there will be bounding box coordinates on it.
Yep.
If you know the bounding box and it's not a super large file,
Yeah.
you can just load it using a ground overlay element. So that the core element is ground overlay. That's the thing that you're looking for. Large files, you need to do some regionation and tiling
Okay.
You
for.
can talk to us after.
Yeah.
And we can
And there's an article on the KML documentation. about
Okay,
doing
cool.
this.
Thanks.
Yes.
I was just going to answer the earlier question. There is a API called Java API for KML, or JAK, J-A-K, and it's hosted on Google Code. It's kind of an early version, but I've been using it for about a year. It has a few quirks, but it does the job.
That's great. Java API for KML, or JAK.
post it on Google Code.
Hosted on Google Code. By the way, Sean and I go to a lot of scientific conferences as well. There is a Fortran library for creating KML. There's whatever language you're going to ask about, they probably will be something out there. I'm not advocating Fortran as a solution, but they say there's lots of math libraries out there for it. So, yes.
For the offset of the polygons, now it's all together. Can we go back to have the regular one with points on demand when we need it? If we have slopes on the polygons, different nodes have different elevations?
Sure. So if you put different elevations at each individual coordinate,
Yeah.
the altitude offset will just kind of overwrite those. It doesn't physically overwrite them, it just ignores them.
Okay.
So if you were to just remove that altitude offset, then all that altitude data would still be preserved in the original polygon.
Okay. Thanks.
Sorry,
So-
doesn't the altitude offset simply add the altitude to each of the vertices?
No, I thought it, well,
Okay.
I think it just overrides it, but
There seems to be some,
I can find out for
Yes.
you.
Okay, so another one is if I have, let's say, a shapefile with Z elevation for each node. So is there a way to bring those automatically with the elevation, with the Z value for each one of them? Is there something out there that export?
if you
The third dimension.
convert a KML file directly, shapefile directly to KML using, as Sean says, Goodle, as I say, GDAL, and as other people say, GDAL, there's an open source set of libraries that you can use just a command line to do the conversion, or you can do it in Google Earth Pro. So yes, and that will bring along elevation.
So Google Earth Pro, when you import with it, it brings in also the elevation value, right, for
Yes.
each node?
It should,
Okay.
yeah. And the question was, just to repeat, if you have Z data values in your shapefile, altitude values, will those be converted? And yeah, there are also extensions for ArcGIS, like Arc to Earth, that will do export, and they may preserve Z values. So I look at some of those converters as options.
And if you're interested in that, Josh Livney and I are giving a talk tomorrow afternoon on GIS in Google Earth and Maps. That's another talk. And also, the folks from Arc to Earth are here in the Geo Sandbox. So, yes.
Are there tools or APIs essentially for creating vector tiles? I don't know if Google Maps, the web, is using this. I know that Google Maps for mobile has been started to use vector type tiles to save on bandwidth.
You
Are
mean
there any
to
tools
create
that
your
will take
own,
KML and put it into smaller,
to create
essentially
your
chunks of-
own tiles as opposed to using our KML layer or the Fusion Tables layer?
some vector tiles as opposed to using the image tiles?
Oh, I see. So the question is, are there tools for creating vector tiles, which are, vector tiles is essentially for KML, that's regenation. That's actually a concept that's been around for a while. But there's been a lot of people experimenting with passing vectors in the same kind of, the concept was the same, that you're packaging it into these tiles to a Maps application or to Google Earth. I don't actually know of anything specifically in that area that's very good. Do you know anything?
Not so much for Google products. I mean, there's some open source mapping tools that kind of have this concept of tiled vector data. And I want to say one of the ArcGIS extensions, maybe it was Arc to Earth, might do that. One of the tricks you run into is if you're tiling a polygon, you chop it up, you tile it up, and if you want like a border along that polygon, now the original polygon that's been chopped has lines through the cuts, right? So at the moment, Google Earth doesn't really handle that very well. It's something we'd be interested in looking at. But yeah, so I can look online, but offhand I can't think of anything that works really well for KML. There's definitely a need for that kind of functionality, that kind of tool.
Yeah.
All right, any other questions? 3 minutes to spare. Cool.
All right.
Thank you guys. Come
thanks
up
a lot.
afterwards if you have any questions.